Hi guys, so in class we talked about Volta and his experiment. So he built the first battery. So the principle is to have two kinds of metals. So here I have copper and here I have zinc, and in between you have some kind of juice with ions. So here I use a potato, but you can use vinegar, you can use lemon juice, or even tap water. Okay, so inside here you have some kind of chemical reaction. The copper will give away electrons here that are moving to the zinc. So copper will be positive, so this is the positive electrode, that will be the negative electrode, right? And that will generate voltage. So here I have a voltmeter, so this is expected to be positive. Okay, and indeed I'm going to have a positive voltage and I generate 0.9 volts, so almost 1 volt. Okay, however, and a tiny current. The current here is very tiny, so you see I have to use milliamps, so I have about 0.5 milliamps. So if I try to power that small device here, it's a clock, and you have to be careful, it's polarized. So this one has to be to the positive electrode, this one to the negative electrode, and you see that nothing happened because I do not have enough voltage. Okay, 1 volt or 0.9 is not enough. So what you can do, you add another battery, okay, and you're going to double the voltage. For that you need to connect positive here to negative. So it's very much like you have double A batteries, for example. You want to make sure that the positive is close to the negative. So positive, negative. So now I have batteries in series, right? And let's see now if the clock is happy this way. And you see you can power the clock. Okay, so it has enough voltage to be power, and you can verify here the voltage. Let's see, positive to positive here, and you see it's almost multiplied by 2. Okay, so you almost have 0.9 volt times 2. Okay, so you double the batteries, you double the voltage. So this is called in series. Okay, now if I want to measure the current, not much current will be produced. Here I have still about 0.5 or 0.4 milliamps. So that means that load here, that device, needs enough voltage, but the current doesn't need much to work. And the LED, so here I have a LED, it works the same way. You have a long leg here, which is to be connected to the positive electrode, and a short leg. So it's also polarized. Okay, and it's a semiconductor. So it's a red LED. So red LED needs at least 1.5, 1.6 volt to work, but it's willing to work with a little current. Red LED only, because if you have a green LED you need more voltage. So I'm going to connect here and there. Let's see, I don't know if with the light, you see it just lit up. So if I put my hand here, you can see that it's on. Okay, now you can also, here I have another device, it's another load. Okay, so what's happening here, you are converting, so it's conservation of energy. So energy, which is chemical energy because of the chemical reaction, exothermic reaction, will be converted to electric energy, electrical energy. So this is also polarized, so also I have to be careful. So plus to plus, and here I have minus, minus to minus here. I don't know if you can hear. So it's very weak, but it works. Stop.